I want you to imagine, just for a second, that you are sitting in your living room. You're having a coffee, maybe watching some TV, and there's a sudden knock at the door.
Okay.
You answer it, and it's your energy company. They just want to check your meter.
Right. Which is fine, no big deal.
Yeah, fine, no problem at all. You let them in. But then, 30 minutes later, there's another knock. It's them again. They want another reading.
Yeah, I get annoying fast.
And then 30 minutes after that, another knock. Now, I want you to imagine this scenario playing out 48 times a day, every single day, all year round.
I mean, you would probably board up your windows and just completely disconnect your doorbell by day 2.
Exactly.
It is, to put it mildly, an absolute nightmare of an intrusion if we're talking about the physical world.
But here's the crazy thing. That scenario, at least in a digital sense, is exactly what is happening right now across the country.
Yeah, it really is.
Today, our mission on this deep dive is to explore this massive, totally invisible digital transformation happening right under our noses in the UK energy market.
It's huge.
We are looking at the incredible, honestly, kind of mind-boggling technological architecture required to handle this constant, relentless stream of data, and how they do it without the entire national billing system just, buckling under the pressure.
And we aren't just speculating from the outside here either. The roadmap we're using today comes straight from the front line of this transition.
Right.
We are looking at a really detailed document titled Preparing for MHHS with Salesforce Energy and Utilities Cloud, along with this highly detailed architectural infographic that maps out the whole ecosystem.
And what I absolutely love about this source material is the author. This was published in the UK Salesforce Consultants and Contractors community on LinkedIn by Saaniya Qaiser.
She really knows her stuff.
Oh, definitely. If you want a guide through an enterprise digital labyrinth, this is exactly the person you want holding the map. We actually pulled up her LinkedIn profile to get a sense of her background, and wow.
Yeah, impressive.
She is a 13-time Salesforce certified professional, and she specializes entirely in the energy and utilities sector.
Which is a very specific, very complex niche.
Totally. We're talking deep, hands-on development expertise in Revenue Cloud, CPQ, Data Cloud, and complex enterprise integration.
Right.
She isn't just writing about these systems in theory. She is the one actually out there building them for major utility providers.
Which is absolutely crucial, because when you are dealing with critical infrastructure at a national scale, theoretical models fall apart fast.
Oh, yeah.
You need the perspective of someone who has actually stared down the data structures, seen how systems fail under heavy load, and figured out how to make them survive contact with the real world.
Okay, let's unpack this. Before we get into the shiny tech and the fancy solutions, we have to talk about the sheer, terrifying scale of the data problem Saaniya outlines in her piece.
Yeah, we had to start there.
Because to really appreciate the architecture, you have to truly feel the pain of the problem they are trying to solve.
And the origin of that pain starts with a 3-letter acronym. EAC.
Estimated annual consumption.
Exactly. For the longest time, this was how the entire industry functioned.
Right. You'd get 1, maybe 2 usage figures per meter per year, and it was largely built on historical consumption patterns.
Yeah, occasionally a human being with a flashlight and a clipboard would come to actually look at your physical meter under the stairs, but that was like once in a blue moon.
Saaniya describes this old regime as quiet and manageable. It's literally just a handful of records a year per customer.
It is essentially a rounding error in terms of modern data storage. I mean, a utility company could basically manage a single customer's entire yearly data footprint on a sticky note.
A sticky note.
Yeah. The infrastructure required to hold 1 data point per year is incredibly minimal. But as she points out, that low data environment is ending.
It is being entirely replaced by MHHS. That's market-wide half-hourly settlement.
Right.
And this is that digital knock on your door every 30 minutes we talked about. We are going from 1 single sleepy annual reading to up to 48 readings a day per meter.
It's a massive jump.
If you do the math, that is over 17,000 readings a year, where there used to be literally just 1.
And that math is just for a single customer.
Right.
When you scale 17,000 readings across a national energy supplier's entire customer base of, say, 5 million homes, Saaniya points out that the volume stops being a simple metric. It starts being a genuine architectural crisis.
Because you are jumping from a spreadsheet's worth of historical estimates to billions upon billions of interval readings flowing in continuously.
Exactly.
Think about it for you, the listener. It would be like checking your bank account balance once a year to get a general vibe of your finances, which honestly sounds kind of peaceful.
Ignorance is bliss.
Right. But contrast that with getting a push notification on your phone of your exact net worth down to the penny every 30 minutes, 24 hours a day, 7 days a week.
It would be exhausting.
The anxiety aside, just processing that sheer volume requires a completely different kind of machine.
What's fascinating here is the why. Why put the national infrastructure through this incredible stress test in the first place?
Right. What's the point?
It is because under MHHS, the entire market is shifting away from those profile-based estimates.
Mm.
Because those estimates are really just educated guesses smoothed over a whole neighborhood.
Yeah.
We're moving towards actual hard consumption patterns. We're moving from a grid that asks, well, what do we think you used today, to a system that declares this is exactly what you used at this exact moment in time.
Because if the grid operators know exactly when the power is being drawn, they can balance the physical load way better. They can buy wholesale energy more efficiently. And they don't have to fire up dirty backup coal plants just because they guessed wrong about the evening energy demand, right?
The environmental and economic incentives are massive here. It improves settlement accuracy across the entire market. That means energy companies aren't holding massive financial buffers just to cover bad estimates.
Yeah, okay.
But, as Saaniya makes very clear, having the data is one thing. Being able to actually use it without your servers catching fire is another entirely. That kind of data influx is basically fatal to a legacy database.
Which brings us to how a modern energy company actually catches this avalanche of information, because you can't just route billions of half-hourly data points into a standard SQL database and just hope for the best.
No, definitely not.
You need a purpose-built engine to catch, sort, and distribute it.
And looking at the architectural infographic Saaniya provided, we can actually see the blueprint of that engine. This is where Salesforce Energy and Utilities Cloud, or EUC, really earns its keep. At the absolute base layer of all this, you have Salesforce Data Cloud doing the heavy lifting. It's ingesting this massive volume of high-frequency data.
Now, hang on. I have to push back on this a little bit.
Go for it.
Because when I hear the word Salesforce, I immediately think of a CRM. I think of sales reps logging phone calls, managing email contacts, maybe tracking quarterly deals.
Right, just the classic sales use case.
Yeah, so why wouldn't these massive energy companies just build their own custom in-house database specifically for meter data? Trying to shoehorn a sales tool into a national grid infrastructure job just sounds like a disaster waiting to happen.
It is a totally valid suspicion, and honestly, it's a trap a lot of utility companies actually fall into.
Really?
Oh yeah, if an energy provider tries to build a totally bespoke data solution from scratch just to handle billions of rows of telemetry data, they take on a catastrophic amount of technical debt.
I can imagine.
What Saaniya highlights in her breakdown is that Data Cloud isn't acting as a digital filing cabinet for sales contacts here. It is an ingestion and harmonization engine.
So it's not just catching the data blindly.
Not at all. It takes these raw interval readings, pulling in from various meter systems all across the country, and it uses something called calculated insights.
Calculated insight.
Yeah, it automatically turns those raw, chaotic pings into actual usable usage patterns at the account level, all in real time.
That makes a lot more sense. Instead of a fire hose of data blasting into a room, it's more like a highly automated postal sorting facility.
That's a great way to look at it.
The letters, or, the data points, are flying in at 1,000,000 miles an hour. But the Data Cloud is scanning the barcode, sorting them, and dropping them into the exact right geographic and account slots in milliseconds. And it does this before the energy company's billing software even has to look at them.
That sorting facility analogy captures it perfectly. But even the best sorting facility is totally useless if the mail trucks can't actually get to the post office.
Right.
That is where the second layer comes in. MuleSoft. MuleSoft sits underneath and acts as the integration layer. It connects this whole Salesforce environment to the wider MHHS ecosystem.
Integration always sounds like such a corporate buzzword, but in this context, I imagine it's actually the hardest part of the entire job.
It is arguably the most complex technical hurdle they face. Because the UK energy market isn't just one single computer.
Right.
It is a totally fragmented web of legacy systems, meter operators, distribution network operators, and data aggregators. Some of these entities are running modern cloud APIs, sure.
But others?
Others are running billing software from 1998 that operates on completely different data protocols. MuleSoft basically acts as the universal translator. It routes data seamlessly across all these disparate, complex external systems without the energy company having to write thousands of lines of brittle custom code for every single connection.
So by using Data Cloud and MuleSoft, the energy supplier is essentially buying a world-class pre-built factory rather than trying to invent their own conveyor belts from scratch.
Exactly.
Catching and translating the data is step one. But now we run into the reality of the physical world. And the physical world is incredibly messy.
Very messy.
People move out of apartments, meters break, wires get upgraded. Where does all this beautifully harmonized data actually live so that it makes sense in reality?
This point was a major aha moment in Saaniya's piece for me. She emphasizes that volume was only half the MHHS problem. The data has to land somewhere meaningful.
Right.
And standard database objects, things like account or contact or case, they simply lack the depth required for the energy sector.
Because an energy customer isn't just a name and a billing address on a screen, they are intrinsically tied to a physical piece of geography that draws power from a national grid.
Exactly. To solve this, Salesforce Energy and Utilities Cloud introduces industry-specific, purpose-built data objects.
Okay, what are they?
Saaniya details 3 critical ones. First, premises, which represents the physical property itself. Second, service point, which is the actual network connection point where the grid meets that property. And third, asset, which is the physical meter or equipment installed at that service point.
I really love this structure. They are actively decoupling the human being from the house and the house from the physical meter.
Yes, exactly.
Think of it like a car. You have the car itself, the chassis, that's your premises. Then you have the engine mount, the space designed to hold the power source, that is your service point. And then you have the engine itself, which is the asset, the actual physical smart meter.
If we connect this to the bigger picture, that completely changes the game from a data architecture standpoint.
Because you can sell the car to a new driver, right? That's a tenancy changing.
Right.
A new tenant moves in, the old one moves out. But the chassis, the premises, doesn't move.
Right.
Or let's say the engine blows out and the utility company installs a new smart meter. They swap the engine, the asset, but the engine mount, that service point connection history, stays exactly where it is.
It's brilliant because it prevents the system from getting amnesia every time someone moves house or upgrades their hardware.
Yeah.
The history remains totally intact.
So when those billions of half-hourly interval readings flow in from Data Cloud, they don't just attach to some generic customer file for John Smith.
No, they relate back to that specific account premises service point asset hierarchy.
Wow.
It ensures that the history of a connection point outlives any single tenant. Everything built on top of this, the billing, the forecasting, it all sits on a clean, solid, real-world foundation instead of a precarious web of custom logic.
Here's where it gets really interesting, because everything we've talked about so far is back-end architecture.
Right, the plumbing.
It's the plumbing. And while brilliant plumbing is essential for the house not to flood, it's not exactly thrilling for you, the listener, sitting in your living room paying your monthly bill. Why does this architectural marvel actually matter to the consumer?
Because, as Saaniya brilliantly observes in her breakdown, MHHS isn't really a data program at all. It is a product transformation program disguised as a data program.
Wait, we just spent 10 minutes agonizing over billions of data points, and now we're saying it's not about the data.
Well, the data is just the key unlocking the door.
Oh, I see.
Those half-hourly interval readings matter because they unlock entirely new consumer propositions. The industry is shifting from a model that bills based on averages to a model that prices based on behavior.
This is the payoff. This is the era of time-of-use tariffs.
Yes, time of use or TOU tariffs are the ultimate goal here. Because the supplier now knows exactly when you are drawing electricity from the grid, they can offer products where the rates vary dramatically by the time band.
Instead of just charging one flat rate all day long regardless of grid strain, we are talking about things like an EV saver tariff, where it literally costs pennies to charge your electric vehicle at 2 in the morning when the wind is blowing and demand on the grid is practically zero.
Right.
But it costs a massive premium to run your tumble dryer at 6 in the evening when everyone in the country is getting home from work and turning on their ovens.
To make those dynamic tariffs work, Saaniya points out the absolute necessity of the product catalog. A TOU tariff isn't just a single line of code. It's modeled as a product with distinct attributes.
Like what?
Well, you might have one attribute for the morning price band, one for the afternoon peak, and one for the overnight dip. The price catalog sits alongside it, holding the actual rates for each of those bands.
Plus the standing charge, right?
Yes. Yeah. Plus a standing charge, which is a fixed daily fee independent of your consumption and any administrative management fees.
So launching a new tariff to respond to, say, an energy crisis or a sudden surplus of wind power isn't some massive IT project taking 6 months anymore.
No, not at all.
Saaniya mentioned that launching a new variant basically becomes a configuration exercise. They can snap these reusable pieces together in the catalog, almost like Lego bricks, to push a new tariff to the market instantly.
And that agility is vital when wholesale energy markets are fluctuating wildly.
So if a supplier can spin up these tariffs so easily, let me put myself in the shoes of the consumer for a second.
Yeah.
If I hear about this amazing 2 a.m. EV tariff, I assume I can't just call up my energy company, demand the tariff, and get it blindly.
Definitely not.
There must be some kind of system checking if I'm actually eligible. Otherwise, people would just sign up for tariffs they can't even physically use.
You've hit on the exact reason why that physical data model we discussed earlier is so critical. The system has to act as a gatekeeper. And this is where a tool called Industry CPQ comes into play.
CPQ.
Yeah, CPQ stands for Configure Price Quote.
What is CPQ actually doing behind the scenes when I call and ask for that tariff?
It acts as the validation engine. When you request the EV tariff, CPQ dives straight into that specific account premises service point asset chain we talked about.
Okay.
It verifies reality. It asks, does this specific property have a smart meter capable of half-hourly settlement? Is that meter actively communicating with the network, or has it been offline for a month?
Oh, wow.
It checks the physical physics of your house before it ever generates a quote. Because if your meter is an old manual spin dial installed in 1998, a half-hourly behavioral tariff is physically impossible.
It prevents the supplier from selling a digital product that the physical hardware can't support.
Exactly.
Man, that saves the customer service team an immense amount of headache. But all this back-end validation, the CPQ checks, the data cloud sorting, what does it actually look like for the consumer? Because I'm certainly not logging into a Salesforce database to check my power usage. I want to see this on my phone.
The visual infographic Saaniya provided illustrates this perfectly. All of these back-end engines are wrapped in what Salesforce calls a 360-degree customer and energy view.
Okay, translating that into the real world.
This is where a tool called Omni Studio comes in. Omni Studio is what builds the digital experience you actually interact with as a customer.
Right.
It takes all that complex CPQ logic and half-hourly data and turns it into a sleek, easy-to-read pie chart on your smartphone app.
So it shows you exactly how much carbon you saved by delaying your dishwasher or how much your EV charge cost last night without ever exposing you to the back-end complexity.
Exactly.
So Omni Studio is the translator between the heavy machinery of the database and the human being looking at their iPhone.
Yes.
And looking at the final piece of this architecture, there is a prominent mention of AI and automation. To avoid sounding like a software brochure, how is AI actually being used here in a practical sense? Because optimizing operations is a very, vague promise.
Think about it at a macro scale. When an energy company has billions of rows of half-hourly behavioral data mapped perfectly to geographic premises, they can feed all that into predictive AI models.
Okay, give me an example.
If the weather forecast predicts a massive 35-degree heat wave hitting London next Tuesday, the AI can look at the historical half-hourly data of those specific neighborhoods. It can predict exactly when the air conditioning units will overwhelm the local substations.
Wow.
And then it can automatically push a temporary, hyper-local tariff to those specific customers via Omni Studio, incentivizing them to pre-cool their homes at 11 a.m. instead of 3 p.m.
It uses the data to actively steer human behavior and physically protect the grid from melting down.
Exactly.
That is a completely different universe from a guy with a flashlight writing a single number on a clipboard once a year.
It really is.
So to bring all of these threads together, what we've explored today is how the UK energy market is undergoing a fundamental structural rewiring. The massive invisible architecture running quietly in the background, Salesforce data cloud catching and sorting billions of pings, MuleSoft acting as the diplomatic translator between legacy and modern systems, and Energy and Utilities Cloud accurately modeling the physical reality of our homes and meters. All of this is exactly what allows energy suppliers to survive the MHHS data avalanche. And ultimately, it's what will allow you, the listener, to save money by shifting your energy behavior.
Yeah.
It's making the national grid smarter 1/2 hour at a time.
This raises an important question, though. if we project this technological capability into the near future.
Oh,
Saaniya highlighted how pricing becomes entirely based on behavior.
yeah.
But human behavior is notoriously lazy, right? We don't want to constantly check our phones to see if electricity is cheap right now.
Definitely not.
If every appliance in our homes becomes smart and our energy pricing becomes perfectly dynamic down to the minute, will we eventually see a fully automated machine-to-machine energy market?
What do you mean?
A world where our houses, utilizing this exact same data infrastructure we just talked about, autonomously negotiate, buy, and trade power with the grid completely on their own while we sleep.
That is a wild concept to leave on. The house literally becomes its own high-frequency energy trader. Your heat pump checks the CTQ logic, realizes wholesale power is practically free at 3:44 a.m. due to high winds, and just turns itself on without you ever lifting a finger.
That is the incredible potential of this shift. And it all traces back to those 48 digital knocks on the door every single day.
A massive thank you to Saaniya Qaiser and the UK Salesforce consultants and contractors community for this incredible look from the front line of grid modernization. And thank you for joining us on this deep dive. Next time you flick a light switch, just remember the billions of data points rushing through the dark to make it happen. See you next time.